It's all about factoring. E is all about getting them in sets of 4. Y times Y times Y times Y times Y. Y to the 5th, right? Don't forget your index when you write your final answer. What do I have left inside? A 5, an x squared, and a y. 2 x squared y to the 5th times the 4th root of 5 x squared y. How many got that one correct? Okay. Questions? Kaylin.
How did you factor the 80?
Into 10 times 8. 10 is a 2 times 5. An 8 is 2 times 2 times 2, or 2 times 4, and a 4 is a 2 times 2. I mean, did you not factor 80 that way?
I did it all. I skipped over.
Okay, actually, let's see. Am I off somewhere? Let me make sure I'm right. I'm right. Yeah, that's correct. Okay, why did you skip the 80, Kaylin?
Because I didn't know how to do it.
Okay, so this goes back to like pre-algebra, factor trees, factoring the prime numbers. Whenever you have a number with a 0 on the end, it's best to take a 10 out first, and you're just factoring the prime numbers. And notice again the kinds of things I tried to teach you guys when we first learned how to factor. Cross off the thing you factored so you know it's gone, right? The 80 became the 10 times 8. The 10 became the 2 times 5. That's why I'm crossing them off. The 8 became the 2 times 2 times 2, so I cross it off because now the 8 is a 2 times 2 times 2. Now I see I have 4 2s. Good, I need 4 of them. I get a 2 out. Can't get the 5 out. Now, let me show you one thing with the y's. If you really got a good handle on math, I could have made the y to the 21st instead y to the 20th times y. Does 4 divide into 20? What's 20 divided by 4? Y to the 5th. Now I chose 20 because I knew 20 divided by 4. If the index would have been 5, I would have still used y to the 20th because 20 is divided by 5 evenly. If the index would have been 6, I could choose y to the 18th because doesn't 18 divide by 6 evenly? And tell me how many y's. Or I can split it up the long way. Again, a few of you that have a handle on numbers, you can handle that. The others of you got to just go in 4s. And look, see, here's the issue. How long have I been after you guys to learn the exponent rules? Forever, yes? And some of you still don't have them. You don't have them down. If you don't have them down, you're not quite sure this is what it is. But isn't 4 of them plus x to the a times x to the b equals x to the a plus b? 4, 8, 12, 16, 20, 21 of them, right? And it's coming out of our knowledge and understanding of what things are. Look, is there anything hard there? Oh, my soul. You know, I could give a kid a plate and say, take out the 4 M&Ms. What was it you took out? M&Ms. They just took the 4th root of the M&Ms. Take out the 4 lollipops. What did you take out? Lollipops. Oh, you just did the 4th root. That's all we're doing. 4th root. You need 4 of them. The root is them. A lollipop. A 2. The root is them. A y. That's all you're doing. That's what the root means. Okay, try the f. Try the fifth root. Again, same thing. I'll do it as you're doing it. Fifth root. All right, so I'm not even going to factor the 12 because in my brain I know there are no 5 terms of anything in a 12. I'm not going to waste my time. If you did, fine, but you found out you wasted your time, right? Were there any factors of 12? 5 of them. No. Now, again, you can if you want, but I'm not going to waste my time. I know there's not 5 of them. Andrew?
What is 2 and 12?
Say again?
I did 2 plus 2 plus 2 plus 2. All the way
Well, you can't do addition. Addition isn't factoring. It's got to always be, good thought though. That's creative, but it's got to be multiplication. All right, got to be multiplication. All right, so hopefully your A's, a lot of you would have said a to the 5th times a to the 5th, right? So I did my A, so I get an A out for that a to the 5th. I get a second A out for that a to the 5th. The A's are done, right? Hopefully of the 17, there's 5 of them, 10 of them, 15 of them, and there's the other 2 of them, 17 of them. Get a B out for those, second B out, third B out, B cubed. That's it. Everything else is left inside. I got a 5 index. I still have a 12. I've got a B squared and a C cubed. A squared, B cubed, times the 5th root of 12, B squared, C squared. How many got that one correct? Okay, we're getting better. Questions, Raquel? Why wouldn't I what? Oh, because I did in my head and said I don't have 5 of anything. You got 2 2s and a 3, yes? Look at your paper. Do you have 2 2s and a 3? Do you have 5 2s? Do you have 5 3s? I don't have 5 of anything. Can't do anything with it. Can only do something with it if there's 5. Now look, Raquel, if it were a square root, I'd be factoring that 12 because I'd have 2 2s. Square root would work. Cube root wouldn't work. 4th root wouldn't work. And this 5th root doesn't work for the 12. It's not enough of anything. We had plenty of A's, though. Plenty of B's. C's the same thing. I don't have enough C's. Not enough of them. I only have 3 of them. I need 5. I need 5 of them. You need 5. You need 5 to take a 5th root. Got a 5. It's about the index. It's all about the index. All right. Again, it's not sinking in yet. My advice is read the text and work some more problems, and hopefully the light bulb will go on. Okay, number 4. Remember, you take the root of, and this comes into play with what Andrew just mentioned, you take the root of factors of the radicand, not sums of the radicand. So, can we take the square root of this? What do you get if you take the square root? What do you get? A minus B. Do you know why you get A minus B? You know, I'll write this out. You agree that's the same thing? Oh, whoops. I wanted my purplish. There's 1 of them. There's 2 of them. And to take a square root, I need 2 of them. And the answer is them. Right? And A minus B. You can look at it, as, okay, so square roots undo squares. But again, that's why. Square roots undo squares. So remember, in the second example B, this is a quantity 2x plus 5 times a quantity 2x plus 5 times a quantity 2x plus 5. So the cube root is 2x plus 5. 2x plus 5. Lions and tigers and bears, oh my. All right. Now let's see if you're really comprehending. Try C. Try C. Doing a square root. Do the square root of C. Probably 3 of you will get it right. Just telling you. So that means you better start thinking outside the box, or really inside the box. I already defined the box for you, but you may not have caught it. I'm only going to give you a minute on this because most of you won't get it. And if you know what to do, you're already on your way. And if you don't, you don't. Again, maybe less than 3 will get it right. All right. Anybody confident they have the correct answer? Let me see your hand. Josh, what's your answer? Not correct, but you took a shot. Who else? Who else? Who else? Andrew.
And square root of 2n plus 1.
No, but you took a shot. Who else? Anybody else? Madison.
N plus 4 n plus 1.
N plus 1 plus 1, so n plus 2?
N plus 4 n plus 1.
Oh, n plus 4, n plus 1?
N plus 4 n plus 1.
No. You took a shot. N plus 4, n plus 1. No, you took a shot. Anybody else? Think they have the correct answer. Kaylin?
2n plus 1.
No. All right. Ileana, what do you got?
N plus 1.
That is the correct answer. Anybody else have n plus 1? Veronica, I would think. Nice, Natalie. Awesome. Okay, now, let's go back and look at something. There is definitely a reason. There is definitely a reason I stuck this here. We've been talking about concepts of what's the radicand of this square root? It's a what kind of polynomial? It's one thing, right? It's a trinomial. Isn't the n squared tied to the 2n by addition, which is tied to the 1 by addition? Isn't it all one thing? We don't have any factors we can take the square root of right now. There are no factors. It's one thing. Unless, of course, all right, before I do what I'm going to do, if I gave you this, don't write it. No, I can't do that. Let's do this. If I gave you this, square root of 20, wouldn't you go 4 times 5, square root of 4 is 2, 2 times square root of 5. Wouldn't that be what you'd do? So what would you do to the 20? You would, so how many factored the radicand? 3 of you, all right? The rest of you, you didn't factor at all. And isn't that what we've done every single time? Factored? I'm going to factor it. Oh, it's a trinomial. I'm thinking trial and error. Like last chapter. Right? Remember, math builds. Things we learn to use. The fronts have to multiply to n squared. How about n and n? Now, I got a positive 1. I can only use 1 and 1. Do my outers and inners give me a 2n in the middle? Oh, they do. Oh, you know what? That's the correct factorization of that trinomial. What is the square root of n plus 1 times n plus 1? N plus 1. Don't I have 2 of the same factor? Can I take the square root when I have 2 of the same factor? What's the square root of 2 jelly beans? Jelly beans. Right? The whole parentheses, n plus 1, is the jelly bean. I have 2 jelly beans. 1 jelly bean, 2 jelly bean. The square root is the jelly beans. Okay? All right. See if you can do D. See if you can do D. Before I do, anybody think they have it? Anybody think they got it? All right, a few of you. You know, our preacher preached last night on the 8th commandment of the 10 commandments, thou shalt not steal. 10 commandments are important. We've gotten rid of them in our society, and our society's a mess, isn't it? So thinking about the law, What is the first law of factoring? How many of you applied it? And here's what I have to say to the rest of you. You got to remember the first law of factoring. Right? So you get 9 times the quantity 4x squared minus 4x plus 1. Yes? Whoa. Yeah. 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 4 times 9 is 36. Yeah. 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 Okay, so if you're going to keep factoring, you're going to try to factor this trinomial, right? You have 2 choices. 4x and x, or 2x and 2x, yes? 2 different choices with a 4x squared in the front. Remember, the fronts have to multiply to the front. In the back, I have a 1. I got to use 1 and 1, but what's my middle and negative? So the only thing I can try is negative 1 times negative 1. Does that give me the proper middle term for the outers, negative 2x, and inners, another negative 2x? Oh, yes, it does. That is the factorization of that. So, did you take the square root of 9 and get 3? Did you take the square root of 2x minus 1 times 2x minus 1 and get 2x minus 1? Did you finalize your answer using the distributive property and get 6x minus 3? Everybody get it? Good job. Doesn't it make sense? Aren't we factoring? Isn't that how you take roots? You factor? Isn't it? Didn't we learn how to factor last chapter? We did. How many of the same thing do you need to take a square root? 2. If this would have been a cube root, we could do nothing, right? We got 2 3s and 2 2x's minus 1s. We wouldn't be able to do anything if it were a cube root. It wouldn't be enough. Sometimes we'd have something stuck inside. What if the common factor I factored out was a 5 and all this was the same? The 5 would stay underneath and only the 2x minus 1 would come out. Which, by the way, let me just show you this in a minute. Just watch. Look up here for a minute. What if perchance that's what happened and this is what my radicand looked like? So I would say to myself, oh, I can take the square root of the 2x minus 1s, right? And I would be left with that. Is that good? Just like that. Am I good? Am I good? Here's the analogy. All right, I'm going to show you an analogy. And you should look at your test because some of you probably have this rule wrong on your test. And this is what you wrote on your test and I marked it wrong. And why did I mark it wrong? Because what do you not have? And the parentheses matters. With the parentheses, it's whatever a plus b equals times the x. And without the parentheses, it's an a plus just the b times the x. So what do I really need technically to do on the radical? In that case, I need a parentheses out there, right? Because isn't it the whole 2x minus 1 times that square root of 5? See, things go together in math. Just like I need the parentheses here, I need it there. But again, some of you still, parentheses, no big deal there, and no big deal there, and then you're off a little bit. All right. Info direct. Let me shut this thing.